Hello again, class. Welcome to another adventure into earth science. Today, we are going to focus on minerals and how we can identify them. As a quick recap, because all this ties together, if you remember in our first section, we learned all about the general makeup of the earth. We learned how there are different tectonic plates all around the earth, and when these move, this old planet starts its shaking, right? The plates hit and slide and do all kinds of things to create volcanoes, earthquakes, and more. In the last section we just did, we learned how rocks are formed and how the formation of these ties into the movement of the Earth. We even made our own diagrams to show the rock cycle, remember? Here's mine I put up on the board. We learned that different rocks can often be easily identified by what they look like. This obsidian is glassy, and we know that it is because it's igneous. It has to be melted down and cooled. Then we have this nice piece of gneiss. We learned how this is a metamorphic rock, and we can even see the striations, or the lines in it, form from where it was squeezed together with a lot of pressure. Finally, we learned how sedimentary rocks, like this sandstone, are made up of bits of things that have been deposited by weathering and erosion. Well, just as we can identify rocks, we can also identify specimens of minerals that make up those rocks. Today, we are going to be looking at these pure minerals and seeing if we can identify them. Here you can see 10 minerals that have been categorized based on their hardness. I know what you're thinking. Wow, they all look so different. This is gonna be easy. Well, judging a mineral by how it looks is only part of the task, and it often won't get you far, unfortunately. Take a second to look at this mineral. Okay, you got it? Now, look at this different mineral. Whoa, that's right, you heard me correctly. These are two very different minerals. One is calcite, and the other is quartz. Very different minerals. But wait, the confusion may not even stop there. You remember the picture of calcite I just showed, right? Well, guess what? This is calcite too. Oh, and so is this. And yes, this one is also calcite. So, not only can different minerals look similar to each other, but one mineral sample can also look totally different from another sample of the same mineral. Wow. So, how on earth can I identify the makeup of, well, the Earth? One of the first tools we are going to use is the Mohs hardness scale. No, not that Mo. One property of minerals is that they have specific makeup of elements that give them the toughness or hardness. This does not change. Using Mohs hardness scale, we can see that poor talc will always be at the bottom of the list because it has a hardness of 1. No mineral is as soft as talc. The hardest mineral in the world is a diamond. So, let's do a quick examination of those two similar looking minerals we had, calcite and quartz. While they may look the same, sometimes, they have vastly different hardnesses. So, we can perform a quick scratch test on them. Quartz will always scratch calcite because it has a hardness of 7 and calcite has a hardness of 3. Okay, but we may need to investigate further to be sure. After all, there are 7 minerals above calcite on the scale, and they will all scratch it. We can also use the other tools we have listed here because we know they have specific hardnesses as well. So, if we take our mineral we think is quartz and try to scratch glass, and it does, we can be sure it isn't fluorite, apatite, or orthoclase, which is commonly known as feldspar too, because those 3 are below the hardness of glass and could not scratch it. Does that make sense? Okay. There are other methods we can use to narrow down our mineral's identity too. We can use a streak test. Different minerals will leave different colored streaks when they're drawn across unglazed tile. Hematite, for example, will leave a reddish-brown streak. Next, we can identify some minerals by how they break apart, which is known as cleavage, or how they cleave. Some minerals, like mica, flake off in paper-thin sheets, and some, like halite, form perfect little cubes. There are other types of cleavage as well. Finally, there are some minerals that have special properties that make them pretty easy to identify, and frankly, they're just plain fun. For example, magnetite is magnetic. Other minerals have a weird smell, or sometimes they fizzle when they get some acid dropped on them, or different things like that. So, are you ready to identify some minerals? I'm going to get things started, and then you can partner up, and you and your partner have a tray of 13 minerals to identify. Oh, I hate to break it to you, but there are no diamonds in your minerals, so don't try to take any of the minerals home with you thinking you're going to get rich. So, I'm going to put up a mineral identification flow chart up here in this for you to use, and you should all now open your textbooks to page 265. Here you will see another mineral identification chart and also a Mohs hardness scale. So, let's get started. First, see if you can find any white or slightly off-white mineral samples in your kits. Go ahead and gather those up, and I want you and your partner to try scratching each with your fingernail. So go ahead and do that. Did you find one or two that you could scratch? Okay. Compare that to Mohs hardness scale. What are the two minerals that you can scratch with your fingernail? Either talc or gypsum, right? So, what do you have there? Which one? How do you know? Unfortunately, color won't help you here because both are usually white. So, this is where we can get into some of those other special properties that I was mentioning. This one is going to be by feel. Talc feels slippery or even kind of soapy. Gypsum does not. So, rub your fingers on that mineral that you have, or those minerals, and see if it feels slippery. If so, it's talc. If not, it's gypsum. So, go ahead and get out your identification table that has the empty place for minerals and their names. Go ahead and place the mineral beside the identification you think is correct. Now, go ahead and scratch, streak, and identify those minerals. You and your partner will have about 15 minutes to identify each one. Again, use the charts in your book, and I will leave this chart up on here as well. And then we're going to go through the minerals as a class and see what you got right, and see if there are maybe some tricky ones, things that we need to watch out for in the future. And as a last hint, you have no minerals in your kits that are a level 8 on the Mohs hardness scale. All the minerals that you have are level 7 and below, so that should help you out a little bit. So go ahead, take some time. You have 15 minutes. Go ahead and see what we can do with those minerals, see if we can get them right, how many you can get right, and then we'll come back as a class and see what we got right and maybe tell what we can do in the future. So go ahead and begin.